Compound probabilities, once again, this time using multiplication and simulation. On the right-hand side, you see that I have left up my Desmos calculator, my simplifying fractions calculator, and just in case we need it for the rest of this unit, my combinations calculator that we used last assignment to determine the exact number of combinations that you can have when you flip a number of coins to get heads or tails. Let's dive right in and talk about number one. It says a soccer team's kit consists of 2 jerseys, 2 pairs of shorts, and 3 pairs of socks. How many soccer outfit combinations are possible if each outfit contains 1 jersey, 1 pair of shorts, and 1 pair of socks? A reminder that we're going to use what's called the multiplication principle of counting, which says to figure out how many total combinations or outcomes are possible given a number of things, you figure out how many combinations are possible for each individual thing, and then you multiply them together. So in this case, you need to figure out how many jerseys you have, how many pairs of shorts you have, and how many pairs of socks you have. Then you multiply those numbers together, and whatever you get is your answer. So for me, 2 times 2 is 4, and 4 times 3 is 12. As always, make sure that you're using your numbers and not mine, as yours are probably different unless you got really lucky. And if you input 12, you're probably going to get it wrong. The same thing for number 2. Heather finally narrowed her clothing choices for the big party down to 4 skirts, 4 tops, and 3 pairs of shoes. This is a pretty big flex on her part. A lot of choices for Heather. 4, 4, and 3. So we need to multiply those numbers together. 4 times 4 times 3. She's got 48 different combinations, and sounds like a first world problem to be stressing so much about what you're going to wear for a big party, but I get that sometimes that's extremely important. But with 48 combinations, Heather, I hope you can make a decision, because that's a lot of choices. And I'm glad I'm not in that position to have to make it. 48. Alright, so these are like review problems really from last assignment. And then we're going to start getting into some new ones. An ice cream, it's like a little toddler talking. An ice cream comes in either a cup or a dish, and the flavors available are vanilla or chocolate. If you are given an ice cream at random, the probability that it will be a dish of vanilla is blank. Let's remember, first of all, that anytime we see the word probability, that means a fraction. Where on bottom we have the total number of things we care about, or total number of things, period. And on top is how many things we care about. So in this case, we have a cup or a dish. Again, you might have like cup, cone, or dish, for instance. And I've only got 2 flavors of vanilla or chocolate, which again, for you might have more than that. So if I do 2 times 2, I have 4 total combinations. But because now it's talking about probability, we need a numerator on a fraction. And the probability it will be specifically a dish of vanilla is just one specific possibility. So for you, however many choices or outcomes you get by multiplying your numbers together, put that on bottom, and then on top, just put a 1, because you're having one specific combination. And when you type that in, you can use the slash next to the right shift key. That goes up and to the right like that, and then whatever number you got on bottom. Let's stick with the subject of ice cream. One of my favorite foods, really favorite things in the whole world. I love ice cream. My favorite is Tillamook Mudslide. I'm a sort of a chocoholic or a chocolate peanut butter holic, so Ben and Jerry's Half Baked. Tillamook also has chocolate peanut butter. I like mixing some like chocolate chip cookie dough in with some combinations like that. Oh, so good. I'm going to stop talking about that because it's going to just make me more hungry. But now let's talk about a problem that's also ice cream. The ice cream shop offers I have 31, remember, use your number, 31 flavors. You order a double scoop cone. How many different ways can the clerk put ice cream on the cone if you want 2 different flavors? All right, so for this problem, I'm going to draw a cone. And I'm going to say that my first flavor is indeed going to be Tillamook Mudslide. I'm just going to label that TM for Tillamook Mudslide. And I've got 31 combinations for that first flavor. Not only do I have mudslide and cookie dough and peanut butter. I've got these other ones that I personally don't like, these fruit flavored ones, maybe sugar-free, dairy-free, all these options. And then I need to choose a second scoop. But notice what it says. It says you have to have 2 different flavors. So I can't choose mudslide again. So the question is, if I can't choose mudslide, how many options do I have for my second flavor? And say I go with this looks like mint chocolate chip. It's also like pistachio, but again, I'm a chocoholic. So we're going mint chocolate chip. I only have 30 options for this because Tillamook mudslide is the bottom option, and I can't repeat it as much as I might want 2 different scoops of Tillamook mudslide. I got to go with MCC, mint chocolate chip. So then I have to multiply my 2 numbers together, 31 times 30, and that would give me 930, I believe. I can multiply it in my calculator. But yeah, that is how you do it. So you take the number of combinations you have for the first flavor, and you multiply it by 1 less than that. And that's it, because we just have a double scoop cone. Okay. And let me just clarify. I think I'm right, but never know. And it's pretty early in my day. Yeah, 9:30. My mental math is woken up this morning. It's good to know. All right, 9:30. Okay. Number 5. How many ways can 4 people stand in line at the movies? This is one of my favorite problems all year. So I want to ask all of you out there, take a moment, and you all have different numbers, or if you're not in my class, you have no numbers. You're not doing this on your own assignment. But I want to start by talking not about 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I want to talk about 10. So I want to break maybe this large one into 2 smaller gaps. So the question is, how many different ways do you think 10 people can stand in line at the movies? Like different combinations. So say it's you and 9 of your friends. You stand in line first because you're responsible. Maybe you're going to pay the tickets for everybody because you got some big paycheck or something. And then you got one friend behind you and then another friend and all the way down. You're standing at some combination, but then like the 5th person has to go to the bathroom, so then they leave, come back, stand and back now. And all of a sudden you realize, oh crap, I forgot my wallet in my car. You take off, somebody else is in front. You have a different combination. So the question is, if you all rearrange as many different kinds of ways as you possibly can, how many different ways can you all stand in line, single file, in an order? And pause the video now and just shout out a number. Just think of a number that you think it is. Some people say, oh, 10. 10 people? The answer's 10. Or maybe it's like 100 or 1,000. Or really big, it's like 10,000, 100,000. All right. Do you have your guess? Because I'm going to go over it. Here we go. You have 10 options for that first spot, but then someone is going to stand in line. That leaves 9 options for the second spot. Then someone stands in line, 8, and then 7, and 6, and 5, and 4, and 3, and finally 2 and 1. And with the multiplication principle counting still, we are going to need to multiply each of these numbers together. This is a lot to type in a calculator. It's a lot to do with computation. And so there is a shortcut, a symbol that math seems to steal from English, which is what you know of as an exclamation mark, which in math is known as a factorial, where you just type in however many people you have, and that mark, and your calculator will know what you're doing. It only works when you have a number, you subtract -1 to all the way down to 1, and you multiply all of them together. If you're not doing down to 1 like we did before 31 times 30 for ice cream, so we couldn't use this because we didn't go all the way down to 1. So check it out. I'm closing this in 3, 2, 1. All right, time to see if you were right. How many ways is it? Woo! 3,628,800 ways. If you said that exact number, you deserve all the ice cream or all the movie tickets in the world, because that would be crazy impressive. And to prove to you that this actually is what I said it is, I will write it out. You don't have to do this. Okay, don't hit the exponent button on accident like I just did. And there it is. It's the same number. It's pretty amazing. So again, for you, like 4 is what I have. So you'll notice 4 factorial is much smaller than 10 factorial. Okay. And look what it says. That answer is an RIP. Blockbuster. Oh, Blockbuster. You would still be here if you bought out Netflix when you could have for almost nothing. Instead, you thought it was just a temporary fad, and you karmically closed out of business years later. Number 6. One coin is tossed 4 times. How many outcomes are possible? So this one we've done before, where a lot of people will say, hey, 2 times 4, 8. No, because that is the same thing as 2 plus 2 plus 2 plus 2. We don't want a plus in between. Remember, it's not the addition principle of counting. It's the multiplication principle of counting. 2 times 2 times 2 times 2. And that's not 2 times 4. It's 2 to the 4th power. So for you, type in 2 to the power of how many coins you have. So if you have 5 coins, do 2 to the 5th power. You have 3 coins, do 2 to the 3rd power. Or you can manually do 2 times 2 times 2, or 2 times 2 times 2 times 2 times 2. Look what it says with that sweet, sweet coin. Money! Number 7. Some good Southern speak. There are 19 bands participating in a competition. How many ways can first, second, and third place be awarded? Write your answer without commas. So the first thing I'm going to notice is that unlike our standing in line problem, this is kind of like the ice cream problem, where we're not having 19 places for each band. So we're not going to use the factorial button. We're not going to use this exclamation. Instead, like we did 31 times 30 for our scoops of ice cream, this is like having a triple scoop cone because we've got first, second, and third. So we just simply need to do, cancel out some of these. I'm getting a little too much. How many bands you have, that gets your first spot, and then somebody wins first. They can't also win second, so 18. And then somebody also wins second. They can't win third. 17. And then that's it. You're done because you only have 3 places. So do how many bands you have times that minus 1 times that minus 2. And that's it. Is this going to be a music theme pun? You rock! Yes, that is music to my ears. Number 8, in a school lottery. We got a little raffle going here. Each person chooses a 4-digit number using each of the numbers 0 through 9 for each digit. One 4-digit number is chosen from all possible 4-digit numbers. What is the probability of winning the school lottery? Write your answer as a simplified fraction. Raffles are very common fundraisers in school. So let's talk about them. Some of you guys, like me, will have a 4-digit number. Others will have a 3-digit number. Others will have a 2-digit number. And each of these can be 0 through 9. If you've ever been in one of these raffles or lotteries, you know that the numbers can repeat. Like, I could be raffle ticket 7,727, for instance. 7 repeats 3 times. That's just fine. So we have to ask ourselves, how many different numbers are possible on each of these individual digits? 0 through 9 is a little confusing because people think, oh, there's 9 possibilities. Well, 1 through 9 is 9 possibilities, but then if you add in 0, it makes 10 different possibilities. And because it can repeat, there are 10 different possibilities for each digit. And when we multiply those 10s together, you get 10 to the power of how many digits you have. So if you're like me and you have a 4-digit number, you put a 4 up there. You get 10,000, or 1 and 4 zeros. If you have 5, you'd have 5 zeros. If you had 3, you'd have 3 zeros. But you want to know the probability as a fraction, always a fraction, of winning the lottery. So that means, and let's just check that I'm right here, 10 to the 4th power. 10,000 tickets. The odds of winning are 1 out of 10,000. There is just one winning ticket that you hope is yours because you want to win that bike or whatever they're giving away because you're a scholastic reader or you have perfect attendance. Bringing it back for elementary school assemblies, I remember. Okay. Number 9. A bag contains 18 red marbles, 3 green marbles, and 6 white marbles. Ed chooses one marble, replaces it, and then chooses another marble. What is the probability, so fraction? He will choose 2 red marbles. Write your answer as a simplified fraction. It straight up tells you. All right, I'm going to close out of all this. I need to add up all of my digits here, 18, 3, and 6, to figure out how many total marbles I have. I need to add them, not... That's a lot of marbles. I think I've lost my marbles if I think that's how many I got there. 27. I have 27 different marbles. And I want to know about the red ones. Well, how many red do I have? 18. So as a fraction, I've got 18 out of 27. But notice I am doing this twice. So 18 out of 27. Now, because you are doing this twice, you have a choice of either multiplying it by also 18 over 27, or you can hit squared. Either way, you will see this decimal, 0.4444. If we are in our class right now, and you're watching this video, I will have you go to your graphing calculator, and you will hit the decimal to fraction conversion button and see what that spits out. If that function exists here, I still have not found it. So I'm going to just straight up tell you right now, because it's crazy that you might have a different number of marbles than 27, but even though we have different problems, it's kind of like a magic trick where regardless of where you choose the cards that people are asking, you're going to have the same outcome. I guarantee you right now, you can just trust me, that if you type in the fractional equivalent to this decimal of 4/9, you will be right. I promise you that. So for number 9 for free, if you're still watching this video and following along, type in 4/9, and no matter what your numbers are, I guarantee that you're right. And that leaves number 10. Megan picks a card from a deck of cards numbered 1 through 24 and rolls a number cube. What is the probability she chooses a card with the number 7 and rolls an even number? Write your answer as a simplified fraction. Well, let's remember a few assignments ago about rolling an even number. On a number cube or a die, we've got 1, 3, and 5. We've also got 2, 4, and 6. These top numbers are odd. These bottom numbers are even. In both cases, we have 3 out of 6 choices for odd or even numbers. So then we need to multiply that times the probability of drawing a card with the number 7 on it. For this, I only have one number 7 out of 24 cards, so that's a 1 out of 24 chance. And I also know that 3 out of 6 reduces to 1/2. So for you, here's all you have to do. You have a fraction with a 1 on top because 1 times 1 is 1. And then on bottom, multiply 2, representing your 1/2 for your odd or even odds, times how many cards you have. So 2 times, for me, 24 cards gives me 48. For you, do 2 times however many cards you have with a 1 on top and a fraction, and you'll have it. 1 out of 48. Yay! Your mind's still blown about the 4/9 thing? Because I wouldn't blame you if it was. There it is. This has been one of the longer assignments, longer videos, almost 20 minutes. I started looking at this last night, so it's 19 hours, 43 minutes. And there it is. Okay, we are cruising right along through this probability unit. I hope this video, as always, finds you safe, happy, healthy, and well. And maybe you can go get some ice cream, or if you can't eat dairy, some dairy-free version. I'm going to go get myself some Tillamook Mudslide and some chocolate peanut butter and enjoy that today. Best wishes, take care, and I'll see you next time. Bye-bye.